In this video, we are going to talk about the organization of the CPU. So far, we know that different operation that a processor performs is execution of instruction, and the different steps involved are, first of all, fetching the instruction, then decoding the instruction and fetching the operands from the memory, then processing of the data that is performed by the ALU, and finally, after ALU operation is done, writing back the data into the memory. So while executing these instructions, we know that the major components are ALU and control unit that are inside the CPU. However, different types of registers are also required to store the temporary data during the execution of instruction. So let's look at this CPU organization along with the different registers required inside the CPU. So this is the CPU, that is black box, and we are going to look inside the CPU now. First of all, we know that we need to fetch the instruction from the instruction memory. To fetch the instruction, we need to have the instruction address. So that instruction address is stored in the register called program counter. So this is the first register of CPU organization, which stores the address of the instruction that is to be executed. And it is incremented after the instruction is executed so that the next instruction is to be fetched. So the program counter, it stores the address. Now, when the instruction is fetched from the instruction memory, we have different steps that are to be performed during the instruction execution. So during this time, this instruction needs to be stored somewhere. So it is stored in the register called instruction register or IR. So this is the second register we are going to see here. After that, the instruction goes to the decode and control logic. So this is nothing but a decoder and control unit, now which provides these control signals, as we can see. Now the another element that is present in the stage is temporary registers. Now, you must have seen these registers when you have studied the architecture or organization of common processors like 8085, where the general purpose registers are present inside the CPU to provide high speed data transfer between CPU. So there is a register memory present inside the CPU, and these are the registers which can be used in various ALU operations or as also used to store intermediate results by the users. So the register memory and the control unit gives the signal to fetch the operands from this register memory. When the operands are fetched from the register memory, they go to the ALU and the operation is performed. So this is nothing but the execute stage of the instruction. And finally, after the instruction is executed, the results are computed from the ALU and they are stored back into the memory from which they or the destination address specified in the instruction. So now you can see there are two things, the control signals to the ALU, and you can see the write back stage. That is, this is nothing but the write back stage present. Basically, we have seen the 4 different stages and we have seen their operation. So here is fetch. So for fetch we require program counter and instruction register. Here is decode and operand fetch. So in this stage, we require general purpose registers in some organizations. Then there is execute stage. Inside the ALU, we also have some temporary registers for different operations such as shifting or logical operations and so on. And finally, the final stage is write back stage. So we have seen all the 4 stages and we have seen the requirements of it. Now it's time to look at the complete CPU organization with these components. So in this organization, we saw the internal register operations. What if we want to access the external memory? So to access the external memory, we need to provide certain address and control signals to the external memory. So this can be done by this register structure we have seen here. So these are the nothing but control signals. And this register is called memory address register, which contains the address of the external memory that is to be fetched, and the other register is used for storing the data that is incoming from the memory. It is called memory buffer register, which stores the data that is read from the memory for the CPU operations. So these are the registers required for the external memory communication. Okay, so MAR, which gives the address, and the MBR, which stores the read data from the memory. Now let's look at the complete organization of the CPU with the internal CPU bus for the videos.